So far, we have focused on how to calculate various statistics. There are a few statistics and related materials that I have not covered. I will address those here using some of the displays and statistics we calculated from the previous videos to help explain some of the concepts. Let's start with the shape of a data variable. There are three primary shapes we look for in a data set: symmetrical, left skewed, and right skewed. Ideally, we'd like our data variable to be symmetrical. Recall the bar chart and histogram that we created for the number of bedrooms. You can see that a large majority of the houses have either 3 or 4 bedrooms, and while it's not perfect, the data is fairly symmetrical. Let's look back at the histogram now for the price of the houses. As I mentioned earlier, and as you can see below, there are a few high-priced houses in the data set. Thus, this data variable is right skewed. The skewness, left or right, follows the tail that contains only a few observations. Here the tail is to the right. Another way to tell if a data set is skewed is to compare the mean to the median. The mean price was $208,000, which was greater than the median price, which was only $186,800. This is due to the higher priced houses pulling the mean away from the median almost like a magnet. This is a fairly normal occurrence due to the fact that most real data do not fall below 0. This is why data such as real estate prices and salaries are often presented with a median to get a better sense as to where the middle is. Here's a little chart that may be a helpful guide. Keep in mind, comparison of the mean versus the median is not as strong an indicator of skewness as is a visual display like a histogram. You should look at both. I created the following histogram using another statistical package called Minitab for comparison. This will make a few points. This display gives us a little more information as it has organized the data into 9 classes or categories. You can still see a strong tail to the right indicating right skewed data, but you can see a more normal or bell-shaped curve in the middle. You also see how the classes are organized into more rounded values like 80 to 120, 120 to 160, 160 to 200, etc., etc. Now, one can still do this in Excel, but it requires much more effort. My goal here is to provide you with an occasional second look as to how data is presented so you can develop a better analytical skill set. I often find that it's easier to create a frequency distribution by first creating a histogram with bar counts as I have with the previous 2 examples. Let's see what the chart looks like with the following table. Here you can see the class intervals and the counts of how many houses fall into each interval. I also added columns for the corresponding percentages for the counts, as well as a cumulative count and cumulative percentage column. Now let's take another look at the 5-number summary and the box plot. I created a slightly different display for this box plot for price this time. I prefer to use a horizontal box plot. This could just be a personal preference, but I feel it is more pleasing to the eye and easier to explain to a non-statistical person or audience. One good way to do this is by creating a box plot for both variables and putting them into one display. Now I would like to focus on a few values, particularly the ones that show up as stars in the box plots. They seem to be far away from the bulk of the data. We have a tool called a z-score that gives us better insight as to how far is far with respect to a data variable. The z-score formula looks like this. The z-score value translates to the number of standard deviations that a data value lies from the mean. A negative z-score would indicate a value to the left of the mean, and a positive z-score would fall to the right or above the mean. The x is the data value in question. The x with a line over it is called x bar, or mean, or more specifically, our sample mean. The s is our sample standard deviation. This is a good time to mention that our focus is on the fact that we're only going to be working with sample data and thus a sample mean and sample standard deviation. If we could get information about the population, we wouldn't even need to draw a sample. Let's go back to our price variable and focus in on some of the sample statistics shown here. We will start by calculating the z-score for the maximum house price in our data set, which is 416. I'm not going to worry about the dollars or the thousands or any decimals. This will allow me to focus on the calculation and the meaning of the z-score. The next step is to plug in the necessary values into the formula. This means that our most expensive house lies 3.1 standard deviations above or to the right of the mean, and it might qualify as an outlier. More on outliers in a bit. Now, let's calculate the z-score for the minimum value in the data set, which is 118. This means that the least expensive house lies 1.34 standard deviations below or to the left of the mean. That's why it's negative. Hopefully, you can see that the minimum house price value is much closer to the mean than the maximum value. In summary, z-scores help us understand where a particular data point lies or falls with respect to the mean and other data points. One analogy that I've used to help clarify this is to think of a road running east and west from the center of a town with mile markers indicating how far away from the center you are.